Hello everyone. Now we are starting your next topic, that is introduction to network layer, that is in your unit 4. So first point is network layer. The network layer is responsible for carrying the packets from the source all the way to the destination. In short, it is responsible for host to host delivery. The network layer has higher responsibilities than the data link layer because the data link layer is only supposed to move the frames from one end to wire of the other end. Thus, the network layer is the lowest layer that deals with the end-to-end transmission. The network layer is resides above the data link layer. This is the third layer of the OSI model. Next is network layer duties. There are five duties assigned to the network layer: internetworking, addressing, routing, packetizing, and fragmenting. So first is internetworking. This is the main duty of the network layer. It provides the logical connection between different types of networks. Second is addressing. Addressing is necessary to identify each device on the internet uniquely. This is similar to the telephone system. The address used in the network layer should be able to uniquely define the connection of the computer to the internet universally. Next is routing. In the network, there are multiple routes available from source to destination, and one of them is to be chosen. The network layer decides which route is to be taken. This is called as a routing, and it depends on the various criteria. Next is packetizing. As discussed earlier, the network layer receives a packet from the upper layer protocol and encapsulates them to form a new packet. This is called as a packetizing. A network layer protocol called IP, Internetworking Protocol, does the job of packetizing. Next is fragmenting. The sent data can be traveled through different network. Each route decapsulates an IP datagram from received packet. Then the datagram is processed and encapsulated in another frames. Some issues related to the network layer is address resolution, multicasting, and routing protocols. So next are design issues of the network layer. The important network layer design issues include the service provided to the transport layer and the internal design of subnet. The network layer has been designed with the following goals. The services provided should be independent of underlying technology. User of the services need not know about the physical implementation of network. The design goal has greater importance because there are great variety of the network in the operation. The design of the layer must not be disable us from connecting to network of different technologies. The transport layer, that is the host computer, should be shielded from number, type, and different topologies of the subnet user uses. That is all the transport layer want is communication link. It need not to know how that link is established. Finally, there is need for someone uniform address scheme for network address. With this goal in the mind, two different types of services emerge. First is connection-oriented network service, and next is connection-less network service. A connection-oriented service is one in which a user is given a reliable end-to-end connection. To communicate, the user first make the request for connection and then uses the connection to communicate his content and then closes the connection. A telephone is called the classic example of connection-oriented service. In connection-less services, the user simply puts his information into bundles called packets, puts an address on it, and then sends it for the destination. There is no guarantee that the bundle will reach the destination. So the connectionless service is one which is similar to the postal system. First is design from the design issues. First is store and forward packet switching. The This system is made up of following components: carrier equipment, that is routers and transmission line, and second is customer equipments. So host line, it's directly connection to the router via the leased line, and on next host is on the LAN, which is the connection to the router Then host want to send the packet, host 1 want to send the packet, so the communication will its nearest router. The router A will store the packet until it has fully arrived so that the checksum can be verified. Then the packet is forwarded to the next router. This process continues till it reaches the destination host, and this mechanism is called as a store and forward packet switching. Second is services provided to the transport layer. The network layer services are designed to achieve the following goals. First is the services should not be dependent on subnet technology. Transport layer should not be exposed to the number, type, and topologies of the subnet. The network address which is made available to the transport layer must use the uniform numbering plan. The network services can be connectionless or connection oriented. The internet has a connectionless network layer, whereas ATM networks have a connection oriented network layer. The connection oriented and connectionless services both have their own sets of advantages as well as disadvantages. Finally, we can say that the network layer should be provided a raw mean to send a packet from A to B, and that is all. Third is implementation of connectionless services. In connectionless services, the packets sending from host H1 are injected into subnet individually, and each packet is routed independently. So, no advanced connection is established in the required. The packets are called as a datagrams, and subnet is called as a datagram subnet. So the working process is, if the process P1 on host H1 wants to send a long message to the process P2 on host H2, let the message broken into 4 packets that are 1, 2, 3, 4 at the network layer. Then all of these packets are sent to the router A. Every router has its internal table which tells it where to send the packet for each possible destination. Each entry in the router's table is a pair of consist of destination and outgoing lines to be used to send the packet for that destination. As per the initial router, since the destination is F, the packet 1, 2, 3 were first sent to the C, and then E is finally to F. But when the packet 4 arrives to the input A, even though the destination was F, the packet was sent to the C instead of sent to the B. The reason can be a traffic jam along to the ACE path. As soon as I learn about the traffic jam along to the ACE path, it modifies the routing table and later sends the fourth packet via ABDEF, as we discussed earlier. Next is implementation of connection oriented service. For the connection oriented service, a path from source to destination needs to be established before sending any data packet. This connection is called as a virtual circuit VC, and subnet is called as a virtual circuit subnet. Here all the packet with the following the same path which was established before the communication. When this connection opened, the virtual circuit is also terminated. And in connection oriented service, each packet carries an identifier. These identifiers can tell us about the virtual circuit VC that this packet belongs to. Next is delivery. The network layer supervises how the packets are being handled by the underlying physical networks. This handling is known as the delivery of the packets. There are two methods of delivery. First is direct delivery and second is indirect delivery. In direct delivery, the destination host and the one who delivers the packets are the same physical network. The sender can extract the network address of the destination using the mask. Then it compares the address with the address of the network in which it is connected. If these two addresses are identical, then the delivery is the direct delivery. And in indirect delivery, the sender host destination hosts are not the part of the same physical network. In such a situation, packet travels from one router to the other and finally delivers the destination host. Indirect delivery involves one direct or zero more indirect deliveries. The last delivery is always direct one delivery. Next is forwarding. Forwarding is defined as the process of placing a packet in its routes towards the destination. Forwarding is possible only if host or a router have a routing table of their own. A sender, host, or a root will refer to the routing table when it receives a packet, and from the table they will find the route to the final destination. But this simple solution has practically become impossible today in the internet networking environment due to large number of entries required to be made a routing table. There are three forwarding techniques. Many techniques have been invented and tested in order to make the size of routing table manageable. Some of them is next hop method versus root method, network specific method versus host specific method, and default method. So first is next hop method versus root method. The root method is the most basic method in which the information about the complete route stored in the routing table of the host and router as shown in the figure. This makes the routing table extremely large and difficult to manage. In order to reduce the size of routing table, the next hop method is used in which the routing table only the address of the next hop up to the next router instead of information about the complete route. This is shown in the figure. Next is network specific method versus host specific method. In this host specific method, the routing table or the host or router will specify each destination host connected to the same physical network. This increases the number of entries in the routing table and makes it large. But in the network specific method, we only have one entry corresponding to the destination network. That is shown in the figure. That means we can consider all hosts connected to the same network as one single entry. This will reduce the routing table and simplify the searching process considerably. Last is default method. This is one more method of simplifying the routing table. They refer the figure in which the sending host, that is host A, connected to the network with the two routers R1 and R2. The router R2 routes the packet to the host connected to the network, that is N1 network. However, the router R1 is used for the rest of internet. Hence, the routing table, instead of listing all networks in the entire internet, host A will have only one entry called as the default entry, normally defined as a network address 0.0.0.0. Next is forwarding process. In order to explain forwarding process, let us assume the host as well as routers use classless addressing. For classless addressing in the routing table, we should have one row information for each block. This table should be searched on the basis of the network address, first address in the block. But the problem here is that the destination address does not tell anything about the network address. Therefore, we have to include the mask in the table. Therefore, we need to have an extra column to include the mask for a corresponding block. The forwarding module for the classless addressing is shown in the figure. Thank you.